All right, grade 7. We are going to finish now this section 3 of chapter 10. The video last was so long I had to cut it off. Let's just recap real quick. We're talking about experimental probability versus theoretical probability. Theoretical probability, remember, is the true probability of something. Rolling a die, 1 out of 6 that I'm going to get a 4. Theoretical. Me rolling the die 100 times, counting how many times I get a number 4, experimental probability. What I said was the experimental probability is going to be used in statistics to help predict or estimate what's the true theoretical probability when we don't know what that theoretical probability is. If we know the theoretical probability, then the experimental probability is just kind of going through the motions, maybe to help us understand what the link between them is. But usually experimental probability, the goal of it is to try to estimate the theoretical or the true probability. All right, so let's go ahead and move down. We were looking at some different examples here. Let me go down to an application of this, which is important for you to understand. It's called the law of large numbers. Now, the law of large numbers isn't something this is more of a high school topic, but I think you guys are all old enough to understand what this is saying. What the law of large numbers says is this: the more observations are made, okay, the closer the experimental probability will be close to that theoretical probability. Now, let's just say we don't know the theoretical probability or we can't calculate it, then often we might use the word instead of theoretical, the true probability, the reality. Because, for example, right now, if I wanted to know the percentage of people living in Italy that are bald, that number at this moment exists, okay? Nobody knows what that is. Nobody, okay? But it exists because maybe somebody who's bald is going to die today, unfortunately, or maybe someone who had hair is going to lose their hair, less unfortunately, but still unfortunately. So we don't know. That number of bald people living in Italy is going to change every day. So we can never really know. I mean, it's kind of an impossible task to know that. But what we can do is, if we take a good experiment or a survey or a sample, we can find that experimental probability, and that experimental probability will tell us more or less, pretty close, what the true probability is. So, for example, let's just take an easy one, heads or tails again. We know the theoretical probability or the true probability of rolling a heads, this is a heads, is going to be 1/2, 0.5, right? 1/2, 50%, 50-50, however you want to say it, okay? That exists, 50-50. Now, if I were to, let's just say I flip a coin once and I get a tails, what percentage of my flips were tails? 0. Is 0 close to 50? No. It's as far away from 50% as you could be. But think of it like this: if I flipped a heads, what would it be? 100%, which is equally far away from 50%. So flipping a coin once, that experiment doesn't really help us at all understand the theoretical probability. But let's say we did it not 1 time, but 10 times. And this time I got 4 heads. 4 heads. Now I'm up at 40%. Is that closer to my 50%? Yes, considerably closer than 0% what I had before. Okay, but let's say I did 100 times. If I did 100 times and I got 48 of those 100, that means now I'm at 48%. I'm getting even closer to that true probability, that theoretical probability of 50%. If I were to do it 10,000, let's say I got 5,003, well, that's going to be 50.3%. And so what we're learning here, the law of large numbers says this: the more times that I flip the coin, as this grows, the closer my experimental probability is going to be getting to that true theoretical probability, okay? So the more flips up I do, the more confident that I'm going to get a number very close to 50%. In fact, once you get to 10,000, I would guess that it's always going to be 50 or 50 point something, okay, or 49.9 or something like that. You're going to be extremely close to that 50%. That's just how probability works. All right, the law of large numbers, though, is very, very important. This is going to be my big speech to you about why you should not gamble, okay? And this is going to be the reason why you should not gamble. Okay, let's just say we go to Las Vegas. And in Las Vegas, there's lots of these different mechanisms that are going to be using probability and using the law of large numbers so that they are going to win in the end and you're going to lose at the end. Let me make sure I can help you understand what we're talking about here. Let's say this is called a roulette. Okay, roulette works as you spin this thing around. There's a little ball that bounces around in there, and it's either going to stop on a black, a red, or a green. Okay, this green becomes very important. Now, in most modern roulette, there's going to be two green ones. It's going to be 0 and called double 0. Okay, there's going to be two of those. So let's just work out what they're saying here. So usually there's lots of different ways to bet. You can bet on a number, but the typical way is you can say red or black. You say, I want red, I want black. The ball goes around. You think it's pretty close to a 50-50 chance you're going to win. Close. It's not exactly 50-50. So in this first kind, there's actually 37 different spots it can go on to. 19 of them mean you're going to lose. 18 of them means you're going to win. So the difference is only 1/37th. You might think, perfect, that's not a big deal. All right, now if Vegas just had one person playing this one time, this would not be a good deal for them. But Vegas knows something. Because of the law of large numbers, even if that percentage is 1 out of 37, it's actually usually 2 out of 38, okay? Because they usually have those two of them there. If it's 1 out of 37 or 2 out of 38, they know that if they get enough people to play and that number of spins is large, you get into the hundreds and the thousands in a year, tens and maybe hundreds of thousands of spins that they're doing, they know the more times they spin those roulette wheels, the more confident that 1/37th is going to be exactly 1/37th, just like we did with the flipping the coin. When you get to 100,000, it's going to be basically 50% no matter what. Well, the same thing's true with this. So they know they can take that 1/37th of that 2/38. Let's just say in one night, $100,000 is put with everybody coming in on the wheels, which is an underestimate. There's certainly going to be more than that. Let's just pretend it's a very conservative amount. Even if it was just 100,000 euro or dollars that were bet on that one night with, let's just say they have 10 wheels. Okay, they're spinning all of those wheels. That means that 1/37th is going to be for them $2,702.70. Or if they use the new wheel, that's going to be $5,263.16. It's almost guaranteed it's going to be like that if they get enough people. It'll be maybe more or less, give or take a few dollars. Now multiply that times 365 days a year, right? And now just on a few wheels, now we know that Vegas is winning 1 million or 2 million euro. All they're doing is just taking that small percentage, but the law of large numbers says the more they spend it, that's how much they're going to be winning. But realize this 1 million, if that's what Las Vegas or the casinos are winning, that's exactly what all of the different customers coming through together are losing. So when you go to a place like a casino, you think that you might be beating the system, or I'm just going to get lucky. Because of the law of large numbers, Vegas will always win, and the customers ultimately will always lose. Yeah, you might have someone who wins big one time or whatever, but overall, millions and millions and millions and millions, actually billions of dollars each casino makes each year out of people who come to make those bids. They're just playing probability. And the law of large numbers says it's impossible for them to lose. All right. I hope that was clear. We can talk about this in class. It's one of my goals to discourage all of you from gambling. All right. We'll talk to you in class.